Okay. Okay, so let me give you an example. If I say, look at the sum of k plus 1 over k to the k, as k goes from 1 to infinity, what happens to the nth term? So if you take the limit as k goes to infinity of k plus 1 over k to the k, what's that? So what happens to this thing as k goes to infinity? No, it doesn't turn into 1, but does anyone know? Does anyone recognize this? No? Well, you should know this one actually. I'm hoping that. Huh? It's E. That's right. That's right. Right, because this is actually 1 plus 1 over k, quantity to the k. Right, and you know we saw this last time. As k goes to infinity, this thing turns into E. So what does that tell you, right? Since the terms go to E, then this thing has to diverge, right? This thing diverges. Okay. Let me give you another example. Okay, this one is very easy, I'd say. N plus 1 over n minus 1, n from 1 to infinity. What happens? Well, if you look at the nth term, right, as n goes to infinity, what happens to the nth term? It turns into 1, right? The limit of n plus 1 over n minus 1 is just 1. Right? And so you know that this thing diverges. What about, these are all sort of easy, I guess. 1 plus 3 to the n over 2 to the n, as n goes from 1 to infinity. You know, what happens to the nth term? What happens to the nth term? Goes to infinity, right? Right, because this thing here is bigger than this, right? It's bigger than 3 to the n over 2 to the n, right? Bigger than 3 halves to the n. And then as n goes to infinity, you know, this thing becomes infinite. Okay, so this is how you use the nth term test. Okay, and let me give you the proof of it. So why is the nth term test true? So if this thing converges, okay, so suppose suppose the sum is L. Suppose your sequence your series converges to L, right? Okay, that's saying that S of n, which is the sum from 1 to n, right? The sequence S of n converges to L. Right? For this to converge to L just means that the partial sum sequence, right? The partial sum sequence converges to L also. Let T sub n be a sub 1 plus a sub n minus 1. Okay. So create another sequence. Okay, that's just the sum of the first n minus 1 terms. Okay. Then T sub n also converges to L. Right? Does that make sense? Right? You have your sequence, it converges to L, right? The partial sum sequence converges to L. If I create another sequence that's just the sum of the first n minus 1 terms, that's also going to converge to L. Right? Because as n goes to infinity, you're gonna still end up at L. Okay. But then S sub n minus T sub n converges to L minus L. Right? If this guy converges to L and this guy converges to L, then their difference is going to converge to L minus L, which is 0. Okay. But what's this? S of n minus T sub n. What's S of n minus T sub n? Well, that's A sub n. Right? And so A sub n converges to 0. So that gives it to you, right? We see that if your series converges, then the sequence has to go to 0. If your series converges, then the sequence has to go to 0, right? So you have the series. If it converges, then the a sub k have to go to 0. And if they don't go to 0, then you know that this thing diverges. Okay? So this gives us a way of checking if a series diverges. Okay. It doesn't say anything about if a series converges. Okay. So just to make it clear, so be careful, warning. It does not say if a sub n goes to 0, then some a sub n converges. Okay. It does not say that. It says rather, it says if a sub n doesn't go to 0, then a sub n diverges. Okay, which is a different statement. Right? In fact, this statement is false, right? It's not even true that if the elements if the sequence goes to 0, then the sum converges, right? We saw an example, right? If you look at the harmonic series, this thing diverges, though 1 over n goes to 0, right? The terms go to 0, but the thing diverges, right? The terms going to 0 does not say anything about convergence. Okay, it could converge or it could diverge. Who knows? Okay. But if the terms don't go to 0, then you know it's going to diverge. Okay. Okay. So yeah. So at this point, what we have is only this test for divergence. We don't have any test for convergence, but we're going to spend the next few classes creating tests for convergence. Okay. And those will be needed in our final goal. Right? Remember what our final goal is. Our final goal is to take functions and then create infinite polynomials that approximate them, that recover them, actually. Okay. So, and what we're going to need are these tests for convergence to do that, to accomplish that. Okay. Okay, that's it for today.